Hello, good morning. Welcome to this course on cloud computing. I hope I will be able to provide you with a basic introduction about what is cloud computing and the benefits of it. So let's get going. When you hear the word cloud computing, the first thing that comes to your mind probably is something related to this. A cloud, actually, right? Isn't it? So, the word cloud is used here as a metaphor for the internet. So, in other words, we can say that cloud is something which is present at remote location. And let's say you are here, so you are technically far away from cloud. So cloud here stores, it has servers and it has other data centers which are used to store something. Now you might think, what are servers? So servers are actually powerful computers which store something for you. So let's say you are here, so you want to store your photos, you can store it. And the best part about storing this on the cloud is that you can access it from your mobile device, from your laptop, and even from your school. So this is the advantage of cloud. You can access it from multiple locations without having, versus if you just store it on your laptop, you would have to just view it from your laptop. Imagine you're working on a school project, and instead of saving your work on your computer, you save it to a cloud service like Google Drive. So now you can open that project from any device, your phone, your laptop, or even your friend's computer, because it's stored in the cloud, not just on one device. So now, what is cloud computing? uh, Cloud computing is basically a delivery of computing services, such including servers. Like I said, it's like powerful computers, storage, database, networking, and software analytics and things like that. So companies use it to run applications, and it's not just used for storing files, it's used for different purposes. It's convenient because you don't need to worry about running out of space on your device, and it's often faster and even safer than relying on your own hardware. So let's think of some other examples which are much more simpler. So can you think of something? Yes, it's a classical example is the Google Drive I just mentioned. So when you save a document or a photo on Google Drive, it's stored in the cloud and you can access it from any device with an internet connection, whether it is your home, school, or anywhere else. Can you think of some other examples? Yes, it's Netflix. When you watch a movie or TV show on Netflix, you're streaming it from the cloud. The video is stored on Netflix servers and they send it to your device over the internet, so you don't need to download it. Anything else? Okay, it's social media. I know this is much more popular. When you post a photo on Instagram or a video on TikTok, it's stored in the cloud. That's why you can see your post from any device and your friends can view and comment on them in real time. Can you think of some more and apps in the entertainment industry? Yes, it's Spotify. I know you like listening to songs. So when you stream music on Spotify or Apple Music, you're not downloading songs actually to your device. Instead, the songs are stored on servers in the cloud and played over the internet, allowing you to listen to millions of tracks without using up your phone storage. So these are the simple use cases of how cloud is there in your daily life, and it's so convenient to use it. So let's move forward with what is a cloud service provider. So a cloud service provider is basically a company which provides multiple cloud services, easily from tens to hundreds of services, and they can be chained together. That's important. These services can be chained together to form or to create a cloud architecture. These services are all also accessible via a single UPI, sorry, a single unified API. So that's that. Can you give me an example? It's simple. It's the AWS API. Now, what is AWS? I will explain it to you in a while. Now, these services are also charged and they are utilized via metered billing. And this is based on your usage. Usage could be per second, it could be per hour. Can you think of something else? Yes, they have rich monitoring built in. So if there is something wrong, if something is uh, it's something is going wrong, so it can be monitored easily. So in AWS is Amazon Web Services. It is the cloud services by the Amazon company. So AWS Cloud Trail actually does the monitoring. So this is just an example. And these cloud services also provide infrastructure as a service. Now, what is this? I will show it to you in the next few slides. Just bear with me, it will be clear. And more than this, so if a company offers multiple cloud services under a single user interface, but do not meet most of all or all of these requirements, it would be just termed as a cloud platform. And can you think of other cloud platforms? One example is Databricks, it's Twilio, is HashiCorp. So moving ahead with what's the landscape of these providers. So like I've just divided them into three. It's like a top tier one, like these are literally leading the market. It's the Amazon Web Services. It is provided by the Amazon company. This is Microsoft Azure. These are the names. It is from Microsoft. This is the Google cloud platform, as it is evident it's from Google. And this is Alibaba, which is also following up. So these fall in the tier 1 category because these are the top service providers, and which is followed by the middle one. It's IBM and Oracle and Rackspace. So they are following up, and then we have the later ones who are not so popular, but still they are working in this field. So this was just to give you a landscape of how these providers are, just to give you an idea. So what are the other common cloud services? So whenever you go for a cloud service provider, it can have hundreds of cloud services, and minimum these four services would be there. So cloud, sorry, compute, networking, storage, databases. Now you might think, oh, storage and database, they look the same, but there's a difference. So storage is a way to store data, and database is a way to organize and manage data. And networking is like how it's connected internally via different ways, which you will learn in further classes. Compute is what kind of resources you have, how much RAM you have, CPU, and all those things. So RAM, CPU, etc., of all those things. And AWS is over more than 200 services. It's like a very, it's the leading cloud platform uh, today. So just to give you a slight understanding of what these services are. For example, it could be used for machine learning, Internet of Things, for gaming, and there are a lot of them. For robotics, it can be used for satellites. It's used, uh, and there are a lot of services. So just to give you a hang of okay what these are. Now, what are the characteristics of cloud computing? Now it says pay as you go pricing. That means, let's say if you want to use the service for, let's say, 10 days, so you would just pay for only those 10 days. And let's say if you want to use this for 10 months, so then you would just pay for 10 months, not for 11 months. So it saves you a lot of money. And scalability and elasticity, let's say cloud resources can be scaled up or down easily to meet the changing demands. Let's say you want to store a picture. Let's say the picture is 5 MB. It's a small picture, so you can use it. But now let's say you went to your friend's birthday party and you recorded a video, and the video file size is 2 GB. So now you need more storage, and you can directly upload it on cloud. So this is how the size scaled from a small requirement to a bigger requirement. So therefore it's easily scalable. Third thing is high availability and reliability. Now cloud providers, they usually, once you upload it to cloud, so they have like several data centers in different regions. So data centers are nothing but like powerful computers, servers, like stacked together. So that's how they are. So let's say you uploaded a video, so your video automatically gets uploaded to this one and this one, so it's like replicated. So thus, even if, let's say, something happens to data center 1, there's a flood and all the data is lost here, so even though the data is lost in the data center 1, but your video is still available in data center 2, data center 3, so that means it is still available and reliable. Security and compliance, because you upload your data to these providers, so therefore it is always a something, a trade-off, whether you want to upload your data or not, especially when you're working with big companies. It becomes something which the companies must decide. So now, what are the cloud models? So we will look into these. So cloud models are basically into three types. Like, one is the infrastructure as a service, the platform as a service, and SaaS as a service. So what is this? So that means infrastructure as a service means you're providing the infrastructure, the servers, the storage and networking. These resources are provided in this. When you talk about the platform, so it's like they're worrying about the operating systems, runtime environments and databases. And when we talk about the software as a service, so here they are providing custom relationship manager tools, so you don't need to manage any other infrastructure software. So just to get a more better picture about this, let's say these services are here. Like I just mentioned, software as a service, platform as a service, and infrastructure as a service. So usually the Salesforce, the Microsoft Office 365 that we use, we just use it as a software. We don't have to worry about what's going on behind and how the service is maintained. It's none of our concern. So this is usually more suited for customers. Platform as a service, like Heruko, this is a software and this is used for deployment means putting the product live so that it can be used by customers or users like you and I both. So this is like more focused on the deployment side, so this is focused on the developers who develop the application. Now this one here is like infrastructure as a service. This is usually for the admins, so they have a more bigger role to play. So just moving ahead, so just to give you another perspective about the same, let's say you have your data. Now this is you own your IT. These are the three services here: infrastructure, platform, and software as a service. Now y means you, and c means the cloud provider. Okay, so let me just write here so that it becomes clear. So you versus the cloud provider. Now if you own the IT means everything from hardware and everything, so you have to manage everything, right? Everything you are going to do it on your own. However, if you use infrastructure as a service, so you see you're going to do only these things: the data, application, runtime software and middleware, rest everything, right from the operating systems on which the application runs, this one, virtualization, server machines, these will be managed by whom? By the cloud provider. That means if you take infrastructure as a service, so some part of the things, let's say data and application, they are managed by you, whereas these remaining are managed by the cloud. For example, when we go for a more heavy platform as a service, so a majority of the things are taken care by the cloud service provider. You only have to worry about your application and the data. When you take a software as a service, that means you just need to worry about your data, and everything would be taken care of by the cloud. So you see, in the infrastructure as a service, you still have control. You still have control. In platform as a service, you have less control, but when you take software as a service, so you have least control over everything. Now it depends, it does not necessarily mean that, oh, this is bad. It depends on your use case, what you want to do with it. So moving ahead, like again giving you a broader picture with different cloud service providers. Like initially I mentioned, we have the AWS, so this is the Microsoft Azure from here, and this is the Google Cloud. So infrastructure as a service, here we have the platform as a service, we have the function as a service. What is function? I'm going to explain it to you later. Now infrastructure as a service, now as you see EC2, now EC2 means elastic compute 2. Now what is elastic compute 2? It is nothing but an instance type. So you might think that, okay, what it is, what's an instance? So instance is equal to, it's like one running virtual machine. So what is a virtual machine? Virtual machine is a machine which you can use without you actually using it in person. Like you don't physically have the machine with you, it's somewhere on the internet and you're using it. And instance type is nothing but the hardware configuration, like the codes, how much memory, how much disk, so those kind of things. Let me just write here: cores, memory, disk. So what I'm saying is, AWS, like I said, they are all, although the names might be different, here it's called EC2, here it's called virtual machine, here it's called compute engine. So they are all compute related things, and the name is different, their functionality is the same. So so this was just to give you an idea that how different providers view their things. So moving ahead with the deployment models. So what it is, so this is, we have different types of deployment models. That means we have public cloud, private cloud, hybrid cloud, and community. So what happens with public cloud is that services are offered over a shared infrastructure. That means you take services from the cloud, but it is public. That means others will also be able to access it, so it is relatively less secure. For example, AWS has this, and Azure and GCP, so all of them have it. When it comes to private cloud, this is more private. That means it is not accessible to general public. It has a dedicated infrastructure, and it is for exclusive use. It could be used for, let's say, banks, which are regulated. So it's like a regulated industry, and others if required, let's say defense, they will have their own, etc. So they have their own private data center. Hybrid means it's a mix of both public plus private cloud resources, so you can leverage the benefits of both the models at the same time. uh, it could be used for sensitive data, but again it depends on the organization, what are the policies of the organization. And then community cloud is like, it's shared among a specific group of organization with common needs. So it's not that popular, but these three are more popular. So usually healthcare providers use it for patient data management, because in healthcare we need more privacy for the patients. So what are the benefits of cloud computing? So first of all, it's the cost savings. So imagine you are starting an online clothing store. So, and instead of buying expensive servers and paying for the IT staff to maintain them, you just use these cloud services like AWS, GCP, etc. This way you only pay for what you use, which saves money, especially when you're just starting out. So the second is scalability and flexibility. Suppose uh, you develop a mobile game that suddenly becomes popular. So with cloud computing, you can quickly scale up your server capacity to handle the influx of papers. Let's say it become popular and more people want to play that game, and then the demand increases. With and with the demand you can and when the demand comes down, you can scale down just as easily, thus you can avoid unnecessary costs. So how does it improve collaboration? So with collaboration, let's say you and your friends are working on a group project for school using Google Docs or Microsoft Teams, so which allow you to work on the same documents simultaneously, even if you are all in different places. This makes collaboration smoother and more efficient. So that's how you collaborate. How about enhanced security? If you use Google Cloud services like Google Drive or let's say Dropbox, so your data is protected by advanced security measures such as encryption and regular backups. Even if your laptop is stolen, your files remain safe and accessible from another device. So thus it has a better security. How about access to advanced technologies? As a student, let's say you might want to experiment with artificial intelligence or machine learning without buying expensive hardware, because let's say training AI requires GPUs. GPUs are like graphical processing unit graphics processing units, so they are really expensive. So and if you buy them, of course it will be expensive, but if you want to rent out from Amazon, it can be uh, comparatively cheaper, or you can also use Google Colab is also free. They provide free GPUs. So it's something which everyone starting in this must definitely check out. So they offer access to AI tools and computing power, allowing you to run complex algorithms without needing your own supercomputer. Now, when it comes to evolution of computing, so there are basically initially it's dedicated server, then virtual machines, then containers, then functions. So let's study them in detail. So what is a dedicated server? So dedicated server is like a physical server. It's like a it's like a physical server wholly utilized by a single customer. What does that mean? So you have to guess your capacity, how much you want. Let's say you took this physical server, you rent it out, or let's say you bought it. So now you are just storing one photo, and let's say the photo takes this much space. Now the remaining space, let's say this, now this much space is being wasted because you're not utilizing it. So you are basically, you overpaid for this space, so you overpaid. Let's say even in the future, let's say even if you're storing a video and you utilize, sorry, and you utilize more space, still the remaining part is still being underutilized. So therefore you are actually overpaying for an underutilized server. You can't vertical scale means you can't just increase it directly, you need a manual migration. So and replacing a server is difficult, replacing server difficult. So you are limited by your host operating system. Let's say you have a Mac and let's say you want Windows, so you can't change this because it's on a dedicated server. So there is again limitation. So limitation of operating system is OS. And but the advantage is you have a guarantee of what? Guarantee of security, privacy, and full utility of underlying resources. So multiple apps can result in conflict too, another limitation. So multiple apps can result in conflict in resource sharing because you are actually sharing resource. So this is your resource and that is being shared here. So these were the limitations with dedicated server, and therefore something new was innovated. It's called virtual machines. So virtual machines, what do you think virtual machines are? So the best advantage of virtual machines is that you can run multiple virtual machines on one machine. So one new thing that you can see here is the hypervisor. So what is the hypervisor? So you can think of it as a software layer that lets you run the virtual machines. And a physical server, this is again, like I said, shared by multiple customers. So you are just paying for a fraction of the server. Let's say you are just using this. Let's say you are just using this. So you are only paying for this. So you are saving. You're not paying for this. You're not paying for this. So you are just saving. And you'll overpay for an underutilized virtual machine. So in case you are not using it, so you might have to pay for this, but it's totally up to you. So your another limitation which I can see here in the diagram is that you're limited by your guest operating system. Let's say here it's Windows and you needed, let's say, Linux versus Linux is another operating system which you might need, so you are limited by it. And again, the same problem, multiple apps on a single virtual machine can result in conflicts. But the idea is it is easy to export or import images for migration, and you can scale it depending on the usage. So it is still somewhat better. Now this one, container, it's a new technology. So virtual machines can run on multiple containers. Now here you can see something called as Docker daemon. Now what is Docker daemon? It is the, again, is the name of the software layer that lets you run multiple containers. You can maximize and utilize the available capacity, which is more cost effective. So the container is again more cost effective compared to the previous options. Your containers share the same underlying OS, like we also have the hypervisor here, so the OS is same, and multiple apps can run side by side. So this is app 1, this is app 2, this is app 3, so they can run simultaneously without being limited to the same OS requirements. And here it will not cause conflicts during resource sharing. So no conflict during resource sharing. So this is a good takeaway from this. Now the last one that we have is functions. Now functions are managed virtual machines. They are managed virtual machines running managed containers. It's like we are getting into more detail with the advancement. So they are known as serverless computes. It is very famous. Now, what does serverless compute mean? Serverless doesn't mean that they don't have servers. It's just that you don't have to manage it. You just upload the piece of code, choose the amount of memory and duration, and that's it. You're done. So you are only responsible for code, data, and nothing else. It's very cost effective, and you only pay for the time the code is running. See, very efficient. So cold start is a side effect of the setup. It's like once it starts, it takes up some more time. So this is like just a overview. Again, you have the hypervisor. You have the same thing. The guest OS is there. We have the Docker daemon here. Function. You see how little space this is taking. This is taking. This is taking. We only need this and the available space. So we are not paying for this available space. That is the advantage. This is again the available space. So we are not paying for this. We are paying for only this. You're paying for this, and this. So only to the extent that they are running. Now, what are the challenges and limitations of cloud computing? So, like I said, security concerns, privacy and data are of crucial importance, and organizations don't want to relinquish control over their data to cloud providers. Network dependencies, let's say you are, because cloud computing heavily relies on internet connectivity. Let's say you are in a far off place and you want to watch something on Netflix. So uh, and the internet connection is not that good, and since Netflix involves streaming, so the experience might not be that good. Vendor lock-in, let's say you are using AWS for a certain amount of time, and let's say another provider is providing you with some new, or let's say a better pricing. Let's say Google is offering a better pricing, so to migrate to another provider is very difficult because your entire system is made out of AWS. So it becomes quite difficult to switch platforms in the future. It's not impossible, but it becomes very difficult. Limited control, because it involves shift in control from organization to cloud providers, which can be a challenge for those seeking complete control. Like I explained to you before, infrastructure as a service, platform as a service, and software as a service. You remember this? We saw, and then data and application. These are the two things, and in this case, in software, this is what you control, and rest everything is controlled by the cloud. You remember I displayed this, something like this. So you are giving lot of control to uh, the cloud providers, and especially in terms of software, you're giving everything. You just only your data is yours. Rest everything is cloud. So, moving ahead, what are the future trends and developments in cloud computing? Edge computing is simple. It brings computing resources closer to users. Let's say these are clouds, so they are having different nodes. There's a node 2, node 3, node 4. Let's say you are here. Let's say this is node 5. You are here. So this will provide a data on node 5, which is very closer to you. So the advantage is there is low latency. Now, what is latency? Latency means how quickly you can stream the YouTube or Netflix without any delay in the video. So thus the responsiveness improves for real-time application, not just YouTube, but for other thing as well. Serverless compute, like I said, serverless doesn't mean that there would be no servers. It's just that you don't have to worry about anything else. Developers just focus on writing code without managing servers. Who will manage the servers? It's the cloud service provider, which could be, like I said, it could be AWS, Amazon Web Services, it could be the Google Cloud Platform, it could be the Microsoft Azure, any one of them. They are the top providers. Artificial intelligence and machine learning, they enable the development and deployment of AI and ML applications. What's the difference between development and deployment? Deployment means when user actually uses the AI application, user uses it. Development means you are still in the process of making it, so testing and everything is being done. So it these things are also utilized by the cloud services. And the fourth one is quantum computing. Quantum means something like unprecedented processing power, a lot of powerful techniques in computation in quantum computing, which makes it really fast for complex calculations and simulations. So this is again just a brief overview. So and if you have any questions, please email me. And this was just to give you a broad overview. As I go into more details, I would explain it to you using different analogies, examples. But initially I thought, let me just give you a brief overview. So thank you for listening. Have a great time.